Hi guys. Today we're moving back into our factoring book and we're learning a new type of factoring, one that we have not done before. Today's type of factoring, I wrote it in red, it's perfect square trinomials. In your factoring book, you can put this right underneath the X box. Okay, so down here, perfect square. And since it's a trinomial, I put the number 3 over here again. So remember, the number that you're putting on this side is telling you how large the problem needs to be to use that method. So GCF can be used for anything. Box method is if there are 4 terms. Xbox is for 3 terms. And then today's new method, perfect square trinomial, is also for 3 terms. And then we're going to open it up. For today, we're going to do our examples in the top. And we're going to have 10 try on your own to do on the bottom. So you can do 5 over here and 5 over here. Okay, so examples on the top, try on your owns on the bottom. In our first video today, we're going to focus on how to identify if something is a perfect square trinomial. So just how to figure out if we can even use this method, because cannot be used for all trinomials. It's a very specific type of trinomial. And then in our second video, I'll show you how to get your final answer. Okay. So again, we are in the perfect square trinomial section, and you're writing this up on the top, writing this slide up on the top. So this is what a perfect square trinomial looks like. It's a trinomial, so it has 3 terms. And then there are some very distinct attributes that this problem has. So first of all, the first and third numbers are perfect squares, and also they are positives. So a perfect square is something that you can take the square root of. In this generic example, I've made them both variables, but they could also be numbers. So you do want to memorize your perfect squares, 1, 4, 9, 16, 25, 36, right? So those could also be either with our first number or our last number. And then our last number has to be a plus. If this is a minus, it's not a perfect square trinomial. Next, for your middle term can be created by taking the square root of the first one. So the square root of a squared is a. The square root of the last one, so the square root of b squared is b. And timesing it by 2. Okay, so 2ab. The middle term is allowed to be positive or negative. It doesn't matter. So the last one has to be a positive, but the middle one, it's okay, whichever one you want. This is how you can show work on a perfect square trinomial problem. So again, we're going to square root the first term, we're going to square root the last term, and we're going to times it by 2. If you do this multiplication problem and your answer matches the middle term, then we say, yep, it is a perfect square trinomial. All right, so let's try one with numbers. And again, in this video, we're just identifying yes or no, yes it is, or no it's not. Okay, so example, this is still on the top of your factoring book. So I have x squared minus 12x plus 36. So we're going to check our 2 rules that need to happen. So the first rule says that the first and last numbers are perfect squares and positives. So let's check. X squared is a perfect square, right? The square root of x squared is x. And 36 is also a perfect square. The square root of 36 is 6. And it's a positive 36. So far, so good. Yes, right now, this is a perfect square trinomial. Next, we need to check our middle term. To check the middle term, you're going to write down the square roots of the x squared and the 36. So again, the square root of x squared is x. The square root of 36 is 6. And you're going to put times 2 in the middle. X times 2 times 6 is 12x. Now, when you're checking that with the middle term, you're not checking the sign, you're just checking the numbers. So 12x and 12x, those match. So I'm going to say, yes, this is a perfect square trinomial. And right now, that's all we're doing. We're saying yes. All right, so for our next part, or our last part of this video anyway, we are going to do our 10 try on your owns. So you can do 5 on this side and 5 on this side. So 5 down here and 5 in the middle. And what I want you to do is I want you to identify, are these a perfect square trinomial? So do what we did on the last slide. Take the square root of the first number, square root of the last number, times it by 2, and see if it works. And for right now, for these 10 problems, I just want you to write yes or no. So go ahead and simplify these problems, see if they're a perfect square, and then when you're ready, start the video back up and check and see how you did. Okay, so for number 1, I got a yes. It's x times 2 times 4, which is 8x. That's good. For number 2, I got a no. I got a no because the last term is negative, and it very specifically said that the last term has to be positive. So number 2 is a no-go, not a perfect square trinomial. For number 3, I also got no. I got no because when I checked my middle term, it didn't work. You're supposed to do x times 5 times 2, and that makes a 10x, and this was a 5x, so that doesn't work. This is not a perfect square trinomial. But that means that number 4 is a perfect square trinomial because it was the same numbers but with a 10 in the middle, and 10 was what we were expecting. Number 5 is also a yes. For number 5, you get 2x times 5 times 2, and that does equal 20. And remember, the middle term is allowed to be negative, so that's okay that it was a negative. For number 6, I got a no because the last number is not a perfect square. I don't know the square root of 12. Just to clarify, I'm just identifying right now if it's a perfect square trinomial. And I'm saying, no, this is not a perfect square trinomial. That doesn't mean this can't be factored. That just means we can't use this method. We can actually factor this using Xbox. X squared plus 8x plus 12 can be factored using Xbox. So we are looking for a very specific special case, perfect square trinomial. If it's not a perfect square trinomial, that doesn't mean it's prime. That just means you have to try something else, like Xbox. This one would turn into x plus 6 and x plus 2. All right, number 7 is a yes. Number 7 works. It's 7 times 2 times y, and that's 14. Oh, number 8's a little bit tricky. Number 8 is a no. There's a couple different reasons we can say no. First of all, I don't know the square root of 2. And that first number I'm supposed to be able to take the square root of. So that makes it not work. But then I also tried, I saw a GCF. So I took out a GCF and I thought, hey, maybe, after I take out my GCF, maybe it'll work. But after I took out my GCF, now the last number is not a perfect square. So also a no. Now, again, this doesn't mean that it's not factorable. In fact, I already did factor it a little bit, right? I took out a GCF. That's a form of factoring. So just because it's not a perfect square trinomial doesn't mean it's not factorable. Okay, number 9 is factorable, but not a perfect square trinomial. I've got a negative last term. I don't know the square root of 3, like so many things going wrong here. Now, number 10 is factorable. The square root of 1 is 1. This is x times 2 times 1, which is 2x. So that's a yes. Okay, so again, in this first video, we're just identifying, is it a perfect square trinomial? We have not actually answered any of these questions yet. We have not factored anything. We're going to save that for our second video. I'll see you in a little bit in our second video.